With all eyes on the prospect of flying to and potentially colonizing Mars, many modern space travel enthusiasts have hardly bothered to take a gander at the history books. Yes, Mars rovers and starships point at an exciting future, but it's also important to remember that our aim for the Red Planet is not humanity's first go at interplanetary exploration. That's right. For a time, leading space authorities had their sights on landing on our other neighbor Venus. Today's video looks at how that endeavor went, the innovations it inspired, what we learned from our sister planet, and why we probably won't be moving there anytime soon. Let's get started. From the moment Neil Armstrong set foot on the moon's surface in 1969, imaginations have been running off with the notion of exploring new worlds. After all, our very own solar system was home to 8 other planets at the time. R.I.P. Pluto. Interestingly, while the Americans were rightly jubilant over the Apollo program's giant step for mankind, the Soviets had been hard at work with their own ambitious extraterrestrial program, VENERA. Literally translating to Venus in Russian, the VENERA program was a Soviet undertaking aimed at gathering information on the planet long regarded as Earth's twin. The program was chiefly operated by the state-owned aerospace company NPO Lavochkin. All that was known about the planet was that it was relatively close to Earth and that it was the third brightest object in the sky. Observational astronomy preceding the 60s revealed that Venus was almost entirely covered in clouds. Some astronomers were convinced this was a sign of perpetual rainfall, which made it possible that the planet was awash with vast oceans of water. Naturally, the possibility of water also brought faint promise of life. Armed with hope and a significant budget, the Soviets got cracking on efforts to get a better look. On the 12th of February 1961, a Molniya 8K-78 rocket took to the heavens from Baikonur Cosmodrome, Kazakhstan, carrying VENERA 1, the first of a series of space probes. The probe was to do a flyby of Venus without entering its atmosphere, a feat it accomplished by getting as close as 100,000 kilometers to the planet. Unfortunately, no data was recovered because radio contact with the probe was lost before the flyby. Undeterred, the Soviets launched VENERA 2 through 6 during the remainder of the 60s, hitting incremental milestones with each mission. VENERA 3 was the first man-made object to crash onto another planet, while VENERA 4 managed to measure Venus's atmospheric content. VENERA 5 and 6 were redesigned to serve as atmospheric probes, and both managed to record data for close to an hour. Atmospheric temperatures exceeding 300 degrees Celsius and pressure exceeding 26 bar meant that the possibility of water and human occupation of Venus was squarely off the table. All that remained was to get a probe to reach the rocky planet's surface intact and collect data. VENERA in the 70s. The first 6 VENERA missions, which were actually publicized as Sputnik satellite launches to the Soviet public and the world at large, revealed a lot. The determined minds of the Soviet space program were ready to make real history. VENERA 7, the first attempt of the 1970s, was launched on the 17th of August 1970. Several enhancements had been made to this new probe to maximize the chance of a soft landing on Venus. Chief among these upgrades was structural hardening that allowed the probe to withstand pressure of 180 bar and temperatures of about 580 degrees Celsius, values significantly higher than VENERA 5 or 6 had recorded. The probe's interplanetary bus was also designed to remain hitched until the planet's atmospheric buffeting broke the bus lock-on with Earth. This breakoff point occurred at about 60 kilometers above Venus's surface, and the probe's parachute deployed. Atmospheric sensors within the probe also began recording data and soon revealed that the atmosphere was almost entirely made up of carbon dioxide. For context, Earth's atmosphere consists of 0.04% CO2, while Venus's is an incredible 97%. However, the parachute failed a few minutes after deployment, sending the probe into freefall until it hit Venus's surface at about 60 kilometers H. Touchdown. Initially, it seemed that contact with the probe had been lost. However, data reviews in the following weeks revealed that the probe had transmitted data back to Earth, albeit via a weak signal. Oleg Rziga, a radio astronomer, noticed that 23 minutes of data from the onboard sound recorder had been relayed home. Given the freefall and faint transmission signal, the Soviet mission controllers concluded that the probe had likely fallen to its side, with its antennas facing away from Earth. But for all intents and purposes, the probe had worked, and the mission was deemed a success. Therefore, December 15, 1970 went down in history as the first time a man-made spacecraft had made a soft landing on another planet and transmitted data. The probe had transmitted information from Venus for a total of 53 minutes and confirmed the planet's inhospitable conditions. It was later discovered that Lavochkin had launched a second probe, similar to VENERA 7, on the 22nd of August. with a view of landing on Venus shortly after the first. However, this second launch failed, leaving the final stage and probe stuck in Earth's orbit for the next 410 days. The failed second launch was swept under the rug and officially documented under the name Cosmos 359. 2 years later, on the 27th of March 1972, the real VENERA 8 probe was propelled towards Venus by Ammonia M MVL. This probe had seen further upgrades that made it leaner but meaner than its predecessor. On board were temperature and pressure sensors, light sensors, a gamma-ray spectrometer, radio transmitters, and a gas analyzer, among other equipment. Lavochkin's engineers also made an interesting modification to the probe to make it more resistant to Venus's 500-degree surface temperature lithium nitrate. Solid blocks of lithium nitrate, LiNo-3, which have a melting point of 253 degrees Celsius, were placed around the probe's vital electronics. The idea was for the LiNo-3 to absorb the heat that would otherwise hit these electronics directly. Despite a melting point that is half of Venus's documented surface temperature, LiNo-3 requires significant energy to actually shift from a solid to a liquid. In this case, the planet's heat would be the energy converting the LiNo-3 blocks. The time this conversion took would theoretically add to the probe's expected lifespan. In other words, if it took 30 minutes for the blocks to melt, then VENERA 8 would likely last 30 minutes longer than its predecessor. After launch, the craft reached Venus after 118 days. Like VENERA 7, the probe and its interplanetary bus entered the atmosphere with minimal fuss and detached at 60 kilometers. This time, the parachutes held, and VENERA 8 became the second probe to soft land on Earth's twin. The more stable descent allowed more accurate atmospheric data collection. For instance, the photometers were able to highlight a significant decrease in light when the probe descended below an altitude of 35 kilometers. Despite the dip in light, the sensors indicated that visibility on the surface was akin to an overcast Earth day, more than enough for photography. Additionally, Venus's clouds, which seemed endless from the outside, were found to end at higher altitudes than clouds on Earth. The probe's gamma-ray spectrometer was used to relay information on the surface rock, particularly its uranium, thorium, and potassium content. The ratio of these three elements in Venusian surface rock was found to be similar to that of alkaline basalt. All in all, VENERA 8 was a resounding success. The probe lasted a total of 105 minutes on Venus, 50 of which were on the surface. The 22nd of July 1972 had proven to be another landmark date for Soviet and world space exploration. Environmental readings of our neighbor planet were great, but it was now high time for some visual data. Interestingly, VENERA 8 was also supposed to have an accompanying probe, which is now in the history books as the Soviet Academy of Sciences Cosmos 482. However, following its launch on the 31st of March 1972, the spacecraft failed to leave low Earth orbit and broke off into numerous pieces. Some of those pieces, later determined to be gas pressure vessels, fell back to Earth and landed in New Zealand. The Soviets denied ownership of the vessel or satellite the debris may have belonged to. VENERA 9 would take off 3 years later on the 8th of June 1975. The Proton-KD rocket had replaced the Molniya, and it successfully escorted the orbiter and probe to orbit. The redesigned probe was now outfitted with a hemispheric aeroshell heat shield, a circular air brake, and a donut-shaped landing cushion that would absorb the anticipated 7 meter per second descent. In addition to the now standard atmospheric sensors and geological measuring tools, VENERA 9 also carried a radiation densitometer, a nephelometer, and a panoramic imaging system. These modifications and experiments would bring the probe's total mass to 660 kilo, 110 kilos heavier than VENERA 7 and 8. After 2 course corrections, the probe and orbiter reached Venus's orbit on the 20th of October 1975 before detaching. The orbiter would go on to become the first man-made object to orbit Venus, acting as a comms relay for the probe and carrying out a number of measurements of the planet's clouds and atmosphere. The probe entered Venus's atmosphere encased in the heat shield until it reached a 64-kilometer altitude. At this point, the parachutes deployed before detaching at 50 kilometers. The air brake then took over for the rest of the descent. The VENERA 9 probe touched down on the 22nd of October 1975 in one piece. Sensors measured clouds up to 40-kilometer high and considerable concentrations of iodine, bromine, and hydrochloric acid in the atmosphere. The temperature on the ground was around 485 degrees Celsius and pressure was at 90 bar. Signals were looking good and all functions were working well except for one key thing. A sensor cover on one of the 2 cameras was stuck on. This meant only one camera was able to snap pictures, restricting the mission to 180-degree panoramic images, rather than the intended 360 degrees. Despite the setback, the probe had set another milestone of taking the first photos on the surface of another planet. The photos showed interesting things like a lack of shadows, no discernible atmospheric dust, and many uneroded rocks. The probe worked for at least 53 minutes on the surface, matching its predecessor. Subsequent VENERA missions in the late 70s employed the same probe and orbiter format, and they were also launched with Proton rockets. Unfortunately, VENERA 10, 11, and 12 were all plagued with camera issues. Technical modifications increased operation times, but the Soviets just could not get those pesky camera sensor covers to work as planned. On VENERA 10, only one cover popped off, restricting images to 180 degrees again. On VENERA 11 and 12, neither cover came off, so no photos could be taken. The first 360-degree photos of Venusian terrain, which were also the first in color, wouldn't come until 1982's VENERA 13 mission. On that note, we've come to the end of the video. Thank you again for watching, and we hope you'll share the video and give it a thumbs up to help grow the channel. Make sure you subscribe and hit the bell so you won't miss out on more cool space adventures.